In this video, we will see how to use AQtive Guard's new enrichment feature. Specifically, we'll see how the enrichment filters add contextual information to your inventory, which in turn helps to better understand the nature, usage, and potential risks associated with the discovered cryptographic objects. The enrichment feature can be accessed on the AQtive Guard UI by navigating to the Inventory tab on the left and clicking on Access Enriched Data in the top right-hand corner. Before our data can be enriched, however, we need some data. For this, use the Data Sources tab on the left to populate AQtive Guard. In this video, we'll be using data that I've uploaded after scanning an example Ubuntu container image with AQtive Guard's file system scanner. The Enrichments feature uses our proprietary database which compiles cryptographic data from numerous public online sources such as certificate transparency logs, operating system base images, popular code repositories, and more. The enrichment feature then matches the cryptography in your inventory with that in our database. For example, we can see here that 96% of the inventory in our uploaded scan matches with publicly known cryptographic objects in the AQtive Guard database. Diving deeper, we can see that out of the 315 inventory objects that are currently enriched, 303 of them correspond to publicly known objects in our database. The remaining 12 are not recognized in the database, and hence we call them unknown objects. The enrichment feature also provides filters which allow us to include or exclude these publicly known and unknown objects. But these known and unknown values are only the start. There are other fine-grained pieces of information too, as depicted in this diagram. The distribution category shows the different OS distributions where the publicly known cryptographic objects were found in the wild. For example, even though our uploaded scan corresponds to an Ubuntu image, we also see Alpine and Kali in this list because the same publicly known keys and certificates in our scan were also found in other public Alpine and Kali container images and logged in our database. Now we know how widely used a cryptographic object is. Similarly, the package category shows the different public packages which are known to contain or install the publicly known cryptographic objects in your inventory. Each category shows the top 5 filters sorted by object count. At the same time, the AQtive Guard UI provides a search bar to quickly locate specific items. Note that the distribution and package categories only apply to publicly known objects as found in the AQtive Guard database. Since unknown objects are not in the database, they do not have any corresponding distribution and package information. Despite this, enrichments provide other context about unknown objects via the application and path categories, which apply to publicly known objects too. The path category presents file system paths of the enriched inventory objects in a succinct fashion. The goal is to provide useful insights about the relative locations of such objects within a host system. The application category provides a list of applications that the unknown and known inventory objects could be linked to in the system. To predict these applications, enrichments applies advanced reasoning over specific attributes of the inventory objects, such as their file system locations. In this example, AQtive Guard predicts that most of these unknown objects are CA certificates related to the SSL application. To summarize, we saw how to use the enrichment feature to filter cryptographic objects by contextual information such as public presence, distribution, application, package, and path. But to see what makes enrichments truly special, we'll explore a specific real-world use case in the next video, so stay tuned.